So in this scenario up here, which I've drawn on the board, we have an external magnetic field of strength 2 Tesla. We've got a 1.2 meter current carrying conductor, which is carrying 5 amps of current. Okay, and that's oriented at an angle of 60 degrees with respect to the magnetic field. Okay, so first thing you do is use your right hand palm rule. Can you model this scenario without changing this angle? Okay, so I've got my magnetic field going across towards the right. Now this is my current carrying conductor, and as you see it's at an angle of 60 degrees with that magnetic field. This is 90 degrees. So what I have to do is I have to change the direction of my thumb. Now that's telling me that that angle actually does matter. Okay, and I need to take that into account when I do my calculations. So why do we actually use L sine theta at all? Because we can break this up into two components. Okay, the length of this conductor can be broken up into two components. The one component which is parallel to the field and the other component which is perpendicular to the field. So I can break this up into two components. Okay, just like we've been doing with vectors when we did projectile motion and when you looked at vectors again in year 11. Okay, so the part which is parallel to the field is just going to be 1.2 times cos 60. Okay, up here, the part which is perpendicular to the field is going to be 1.2 sine 60. Okay, so I can solve for those values, and it's only the perpendicular part which actually experiences a force in the magnetic field, which is why we use nBIlsin theta, because this value here, if this is the entire length of the wire denoted as L, then this value here is actually L sine theta. So when we do the equation, F is equal to nBIl sine theta, this part here is actually the perpendicular component of the current carrying conductor in that magnetic field. Alright, so now all we do is we just plug our numbers into our equation. We need to follow the correct procedure. Okay, and the correct procedure is, number one, we need to list the equation which we're going to use. The second step is we need to plug in our numbers. Third step, if we need to rearrange, we rearrange. Really important that you plug your numbers in before you rearrange. Okay, and then we evaluate, making sure that we have the correct units, and if appropriate, the correct significant figures. Okay, so number of turns is 1. It's one turn because it's just a straight piece of wire. Okay, if it was a curled loop or something like that, we need to take into account it'd be more than one turn. Straight wire is 1 turn. Okay, B is our external field strength, which is 2 Tesla, given in the question. Our current is 5 amps, again given in the question. Now L sine theta is the perpendicular component of the wire itself in that magnetic field, which is 1.2 sine 60 or 0.6 root 3. Okay, now figuring this out comes out to be 6 root 3 newtons. Okay, and the direction of the force, again, we only take into account the perpendicular part. Okay, so here we do our right hand palm rule. We've got the magnetic field going towards the right. The perpendicular component of current is going up the page. Therefore, my force is going to be into the page. Okay, into page.